Well, in this new playlist, I'm gonna be talking about sentence embedding, but we start from the basic thing that comes to the mind when we talk about sentence embedding, and we are in 2023. So the first thing that comes to your mind is those transformer architecture and those. But you will see in the next few lectures that we will have we will talk about many different paradigms such as CMEs and networks, contrastive learning, and many other things to produce a good representation. But here in this part, we want to focus on self-attention using RNN. And you know what is attention? The basic references that you use are these two important articles which I have explained in different lectures. And so what is attention? As you have seen in this 2015 articles, Bengio, Yoshua Bengio introduced this interesting and important paradigm that can be used for many applications such as machine translation, and you are familiar with these. And then people work on more computational expensive approaches such as a transformer architecture that needs query vector and keys and values. So you need value, keys, and queries to have a multi-head attention. So what is self-attention, which is sometimes called intra-attention, is an attention mechanism relating different positions of a single sequence in order to compute a representation of the sequence. Self-attention has been used successfully in a variety of tasks, including reading comprehension, abstractive summarization, textual entailment, a learning task-independent sentence representation. So this article is about self-attention, that they use it for sentiment analysis. So you're familiar with all of these ideas, that they have queries, keys, and values, and the scale dot product creates this attention. So self-attention is just the process of applying attention to every position of the source sequence. So this is done by creating three vectors, query, key, and value for each sequence. And so this is an a very simple approach for sentence embedding. They just use these word embeddings and then a linear combination of them. And then once you have the matrix X, you get the singular vectors, and you have, for example, if U is your first singular vector, you can create these embeddings. Another idea is just using n-gram features, which is based on compositional n-gram features. Another idea, which is very important, is done by Irina in University of Darmstadt in 2019, which is good for supervised learning. For example, they did it for NLI dataset, natural language inference. For example, this sentence entails another one, or this sentence contradicts another sentence, or this sentence is neutral to another sentence. And so we give it to BERT, and then a pooling mechanism such as just mean pooling, and then we have two vectors. Once we have two vectors, we can concatenate UV and the difference of them, and maybe the dot product, and then softmax classifier. But then another paper came in 2016, even before the sentence BERT, which was this article, which was used for question answering. But this is an important idea in 2016, a decomposable attention model for natural language inference. So we take F to be a feed-forward neural network with ReLU activation. So these attention weights are normalized like this. And another important article is this one in 2016, long short, that they use it for machine reading. I've explained several papers from Mirella Lapata, and these are positive samples that are related to this idea. So I've explained LSTM in some videos, so I escaped this one. And LSTM is different from LSTM-N network, by the way. In this article, I've explained memory networks in a different video, so I can skip this one. And so let's implement just a classifier with self-attention. Our decoder is just a linear embedding from hidden space to number of classes. And my decoder is just a simple linear map from hidden dimension to the number of classifiers. Let's just do it quickly. So we use self-attention, and then this is your query. This is your keys, and you have outputs. And using this, we can consider previous decoder state as a query vector, encoder hidden state as key and value vector. So your encoder is just, your attention is just this linear combination, and this is also called the energy. And BMM torch, that BMM, it means batch matrix multiplier. We always use this when you want to multiply some matrices